Bond energy is used to look at the strength of a bond. The strength of a bond is going to be the amount of energy it takes to take those two atoms or multiple atoms that are found in a bond and break them into individual atoms all by themselves. Strong bonds have high energy. It takes a lot of energy to break those atoms apart, and weak bonds have low energy. A strong bond also happens to have a short length relative to a weak bond that happens to have a high length or long length. Relatively short, relatively long. We can also add into this discussion the number of electrons that are found in that bond. So a triple bond happens to have 3 pairs of electrons for 6. A single bond has 1 pair of electrons for 2 electrons. And then a double bond has 2 pairs of electrons. A triple bond is a very strong bond. It also happens to be short. A single bond is a relatively weak bond, and it is also longer. We can look at a model to show this. We have a single bond. That's a weak bond, and it's also longer than a double bond, which is stronger. It's also a little bit shorter, and then clearly shorter is the triple bond, which is shorter and also much stronger. We can also discuss bond strength by looking at pencils. If we were to try to break one pencil, that wouldn't be very hard to break. If we had a second pencil, it's getting more difficult to break that pencil or that pair of pencils, just like it is to break a double bond. More electrons, stronger bond, harder to break. And lastly, a third pencil adds more stability to that bond, or in this case, the group of pencils. This is very difficult to break. Similarly, pencil idea, easier to break a long pencil compared to a medium-sized pencil compared to a really short pencil. One that you use in a golf course would be really hard to break. Long bonds are easy to break, they have low energy. Short bonds are hard to break, they have